Hey there, let's talk about numbers. Have you ever just stared at a bunch of them and felt a little bit lost? Well, today, we're going to completely demystify the world of numbers you use every single day. We're going to build a super clear mental map so you can read, understand, and compare any number with total confidence. Okay, let's just jump right into the deep end with a classic question, right? Which one of these is actually the smaller number, -10 or -5? Now, your gut might be screaming one answer, but by the end of this, you're going to know the correct answer for sure. And way more importantly, you'll get why it's the right answer. You know, a really great way to think about numbers is to imagine them as a big family tree. And today, we're going to explore the three main branches of that family. The natural numbers, the ones we count with, the integers, which bring negatives into the picture, and the fractions, which fill in all the little gaps. First up, let's talk about the absolute bedrock of everything, the natural numbers. These are the very first numbers any of us ever learn. They're the foundation, the ones we use for counting, anything and everything. So what are natural numbers? Well, it's pretty simple. They're just your basic counting numbers. 1, 2, 3, 4, and on and on and on, literally stretching out forever into infinity. They might seem basic, but trust me, they're the launch pad for everything else. Now, reading really big numbers isn't some kind of magic trick. It's all about understanding place value. See, when you look at a chart like this, you realize that each digit's position gives it its power. Each spot has its own job. Ones, tens, hundreds, thousands, all the way up. And here's a super easy trick for reading any big number. Just chop it up into groups of 3, starting from the right. So you read the first chunk, 4, and then say its family name, million. Then you read the next chunk, 825, and say its family name, 1,000. It turns a scary giant number into a few bite-sized pieces. Simple. And comparing them is just as easy. There are really only 2 things you need to know. First, the number with more digits is always bigger. A 4-digit number is just going to beat a 3-digit number every time. Now, if they have the same number of digits, you just scan them from left to right until you spot a difference. Easy as that. Okay, so we've got the basics down. Now let's expand our family tree a little bit and meet the integers. This is where the number world starts to get really interesting because we're about to go beyond 0. So integers take all those natural numbers we just talked about, but they add 2 crucial new members to the family. 0, right there in the middle, and a negative version for every positive number. So for every 3, there's a -3. They're like perfect mirror images of each other. If there is one single tool that will help you understand integers, it's the number line. Seriously, you've got 0 in the middle, all the positive numbers stretching out to the right, and all the negative numbers stretching out to the left. And here's the one golden rule you need to remember. Any number to the right is always greater than any number to its left. That's it. So let's circle back to that question from the beginning. Which one is smaller, -10 or -5? Well, using our golden rule, if you picture them on the number line, -10 is further to the left, which makes it the smaller number. And if that's still a bit weird, just think about temperature. Is -10 degrees colder or warmer than -5? It's definitely colder, which means it's less. Okay, so we've covered the whole numbers, both positive and negative. But what about all that space in between the integers on our number line, right? It's not just empty space. That's where our third branch of the family, the fractions, comes in to live. So a fraction is really just a way of showing a part of something whole. The number on the bottom, the denominator, that tells you how many equal pieces the whole thing is cut into. And the number on top, the numerator, that just tells you how many of those pieces you actually have. I know. Comparing fractions can feel a little intimidating. But here's the thing. It's not about memorizing a bunch of weird rules. Think of it like having this awesome toolkit. We're about to look at 4 different, really powerful strategies you can pull out whenever you need them. First up, we've got the most reliable tool in the shed, finding a common denominator. The goal is to make the bottom numbers the same, because then you're comparing apples to apples. So we can easily turn 3/4 into 6/8. And now it's super obvious that having 6/8 is more than having 5/8. Okay, our second tool works when the top numbers are the same. And honestly, this quote says it all. If you're sharing a pizza, would you rather have 1 out of 5 big slices or 1 out of 7 smaller slices? Yeah, me too. The piece from the pizza cut into fewer slices is always going to be bigger. Tool number 3 is all about quick estimation. You don't always need a super precise calculation. You can just ask yourself, is this fraction close to 0, close to a half, or close to a whole 1? In this case, 7/8 is almost a whole pizza, while 3/5 is just a bit more than half. So the winner is clear without doing any complicated math. And finally, for our last tool, we have the lightning-fast shortcut, cross multiplication. This is the quickest way to get a straight answer. You just multiply diagonally. So 2 times 5 gives you 10 on one side, and 3 times 3 gives you 9 on the other. Since 10 is bigger than 9, that tells us the first fraction, 2/3, is the bigger one. So, we've met all 3 families, the naturals, the integers, and the fractions. Now it's time for the final showdown. How in the world do we compare numbers when they come from completely different branches of the family tree? It might seem complicated, but there's a really simple order to it. There's one rule to rule them all. First and foremost, just check the sign. Any negative number, no matter what it is always smaller than any positive number or 0. Always. If the signs are the same, then you move on to comparing the actual values. And here's that golden rule in action. It's just that simple. You see -1/2 versus +1, you don't have to think for another second. The negative number is smaller. End of story. Now for positive numbers, it's pretty intuitive, right? A fraction that's less than 1, like a half, is obviously smaller than a whole number like 2. But with negatives, everything gets flipped on its head. Because +2 is bigger than +1/2, its negative twin, -2, gets pushed further to the left on the number line, making it smaller than -1/2. So, we've built this amazing map of the number world, covering pretty much all the numbers you can neatly write down. But that leads to one last, really fascinating question. What about those other numbers? The weird ones, like pi, that just go on forever and ever without repeating and can't be contained in a simple fraction? Well, that's a whole other mysterious branch of the family tree for another day.